Hello students, I am Dr. Satish Chauhan, your chemistry teacher. In this video, we will learn chapter 2, that is Introduction to Coordination Chemistry. In this video number 2, we will consider IUPAC nomenclature of coordination complexes and their examples. Let us consider the IUPAC nomenclature of coordination compounds. Rules for nomenclature. Anionic complex ions. If the complex ion is anionic, that is contain cation and complex anion, then cation is named first, followed by the full name of anion. The names of cation and anion are separated by space. For example, K2PtCl6, potassium hexachloroplatinate 4. Here the name of cation is written first. So cation is potassium. So potassium. So there are 6 chlorines, therefore hexachloro and platinate. K3FeCN6 potassium hexacyanoferrate 3. In the first example, in the square bracket, there is an anion Cl minus. There are 6 such Cl minus ions are present in the complex 1. So it is named first as hexachloro. The metal ion that is platinum is not free. So it is in the square bracket. Hence it is not named simply as platinum. It is named as platinate, since square bracket carries negative charge. That is, name of the metal ion ends with ATE. So therefore the name is potassium hexachloroplatinate 4. Second, cationic complex ions. If the complex is cationic, that is containing cation complex ion and anion, then the names of the ligands present in the square bracket are written according to the order given in rule number 4. The names of metal is written with its valency in small bracket. The names of anion outside the square bracket are then written. For example, CONH36Cl3, hexaamine cobalt 3 chloride. Number 2, CrH2O4Cl2 Cl, dichloro tetra aqua chromium 3 chloride. For some metals, their Latin names are used. For example, copper, cuprum, cuprate, iron, ferrum, that is ferrate, lead, plumbum, plumbate, gold, aurum, aurate, silver, argentum, argentate. Number 3, non-ionic complexes. Non-ionic or molecular complexes are given in one word name. The name of negative ligand is written first, and then the name of neutral is written. The name of metal is written at the end. The valency of the metal is shown in small bracket in Roman figure. For example, CONH3 Cl3. The name of negative ligand chlorine is written first, therefore trichloro. The neutral ligand triamine cobalt and 3. Number 2, platinum NH3 twice Cl4. Name of the cation is written first. Name of the anion, that is negative ligand, is written first. Tetrachloro diamine platinum 4. Names of the ligands. Neutral ligands, they are named as molecules without special ending. NH2 CH2 CH2 ethylene diamine, C6H5 3sp triphenyl phosphine. Negative ligands, the names of negative ligands end in O. Water aqua, NH3 C6H5NH2 nitrosyl and carbonyl. For example, fluoro, chloro, bromo, iodo, cyano, nitro, oxalato, carbonato, etc. Positive ligands. The names of negative ligands end in IUM. NO plus nitronium NH2NH3 plus hydrazinium. Order of listing ligands. If there are two or more type of ligands present in the complex in the square bracket, then the order of naming is negative ligands, neutral ligands and positive ligands. After naming ligands in the square bracket, the name of metal in the square bracket is written with its valency in the small bracket. Then the name of negative ion outside the square bracket is written. For example, CONH3 4 NO2 Cl ClO4, chloro-nitro tetramine cobalt 3 perchlorate. Naming of the prefixes. Sometimes single molecule of a ligand contains the word di or tri, etc. in its name. For example, ethylene diamine or trialkyl phosphine. If the two or more molecules of such ligands are present in the complex, then to avoid the repetition of the words di, tri, the prefixes in the Greek language bis, tris, tetrakis are used before the names of the ligands. For example, COEN2 Cl2 Cl, dichloro bis ethylene diamine cobalt 3 chloride. Oxidation states. The oxidation state of the central atom is shown by Roman numerals 1, 2, 3 or 0 in parenthesis at the end of the name of the complex without space between the two. For negative oxidation state, the minus sign is used before the Roman figure and 0 is used to 0 oxidation state. For example, NaCO CO4, sodium tetracarbonyl cobaltate, K4 NiCN4, potassium tetracyano nickelate 0. Point of attachment: if unidentical ligand has within itself more than one atom which can donate the electron pair, it becomes necessary to show which atom is acting as a donor, and then the symbol of the donor atom is written after the name of ligand with separation by hyphen. For example, NH3 CrSCN6, ammonium hexathiocyanato S chromate, or ammonium isothiocyanato chromate 3. Abbreviations: some ligands possess long and complicated names. While naming such ligands, their short name forms are used in the formula as listed in the table of ligands. Bridging groups: the ligands that bridge two metal atoms in a polynuclear complex are preceded by Greek letter mu. It is repeated before the name of each kind of bridging group. The resulting complex is called as the bridged ligand. Geometrical isomerism. Geometrical isomerisms are named by the term cis to denote the adjacent away positions and the term trans for opposite position. In addition, it is essential to use the number system to show the position of each ligand. For example, in case of square complexes, groups 1, 3 and 2, 4 are in the trans position. 1, 3, 1, 3, 2 and 4, these are present in the trans position. So, for example, trans chloro nitro diamine platinum 2, 1 chloro, 3 nitro, bromo amine platinum 4, 1 chloro, 2 bromo, 4 iodo, 6 nitroamine pyridine platinum 4. Two, 3 dibromo, 2, 3, 2, 3 dibromo, tetramine, rhodium 3 ion. Optical isomers. Dextro and levorotatory compounds are shown either by plus or minus signs or by letters D and L respectively. For example, plus or minus DK3IR C2O4 thrice, that is potassium plus, or D trioxalato iridate 3.